Good day, everyone. My name is Mpolokia Makosha, and with me here I have Lerekumukeshe and Musamtsoning, and we're from South Africa. And the name of our project is the Green Thumb Project. During 2023, our school started a garden that was supposed to help feed our school learners, but nothing grew. In 2024, we were introduced to coding and robotics as a full-time subject. We decided to integrate coding and robotics together with agriculture to help improve the garden. Small-scale farmers around the world do not have proper access to sensor technologies such as soil moisture sensors, water level sensors, and temperature sensors. Without such sensors, farmers have to analyze their farms manually, which could lead to food waste and reduce productivity. The aim of this project is to create a garden that will influence small-scale farmers around the world to start their own gardens using recyclable materials and cost-effective plants. This garden uses robotic components to help collect data for our soil. The engineering goal of this project is to create a garden that will provide organic food for people in the community. Now my partner Musamtsoning will be telling you more about our project.
The world's income is heavily dependent on agriculture, and this sector significantly influences its gross domestic product. According to an article written by Anna Patel, by 2050, most people will be living in cities. Therefore, it is expected that food productivity increases by 70% to meet demand. Water is essential for agriculture, and currently, agriculture consumes about 62% of all water. However, due to environmental changes, the water is not enough for the whole world. Now I'll be telling you the impact that our garden has on the community. Our green garden fosters a positive social impact through hands-on learning and providing food for school learners and local community members. We had a soil manipulation experiment whereby we had to mix dried leaves, dried grass and pig manure to make compost for the soil as the pH levels were low. After the soil manipulation experiment, we realized that the pH levels were getting a bit higher for planting. Now my partner will be telling you how the sensors in the greenhouse work.
Good day, everyone, and I'll be telling you how the sensors work in the greenhouse, and they will be demonstrating how they work. Firstly, I have a distance sensor and two motors from the spike kit. The distance sensor will sense motion and activate the two motors to roll up on it so that I can see inside our greenhouse. For smart irrigation system, we have three different sensors: the soil moisture sensor, the water level sensor, and the TDS sensor. The soil moisture sensor will sense if the soil is dry or moist and will activate the pump to pump up water into our irrigation system. The water level sensor will sense if the water in the small tank is full or not and will deactivate the pump in the big tank from pouring water into the small tank. The TDS will sense if the water in the small tank is clean or not and will show the readings on the LCD screen. For safety measures, we have two different sensors, the gas sensor and the flame sensor. They will sense if there is any flames or gas leaks around the greenhouse and will make an alerting sound to alert the owners. This is a PR sensor which works with the motor under the sprinkler. The PR sensor will sense motion and will activate the motor under the sprinkler to turn so that it can scare pests away. For small pest problem, we decided to add a garlic water spray system that uses water drips to irrigate because the smell of garlic is unpleasant to many pests. It will make them avoid eating our plants and provide nutrients like potassium and promote growth. This is a dust sensor. The dust sensor will sense if there's any dust around the greenhouse and will activate the fan to blow it away. Now I'll hand it over to Musa to tell you more about our sensors.
This is an LCD 1602 screen which shows all the data collected using the different sensors in the greenhouse. This is a pH sensor which shows the pH level in the soil from a scale of 0 to 14. From 6.5 to 7.0, the soil is considered to be normal, meaning we can plant in the soil. From 7.0 to 14, the soil is considered to be alkaline, meaning we cannot plant in the soil. As you can see, we managed to use the pH sensor microbit to collect data from the soil. This is a light sensor and a UV light. If the light sensor senses darkness around the greenhouse, it will activate the UV lights to turn on so that they can act as the sun to the plants, adding more flavor and taste to the plants. Now my group member will be telling you about our harvesting board and the rainfall sense.
This is a rainfall sensor. A rainfall sensor measures the amount of rain that comes into the greenhouse. For the future improvements of the garden, we decided to include a harvesting bot that can work autonomously and can also be controlled manually using a tablet. I would like to thank you for the time you have given us. Thank you.